Good day, everyone. Today, I'm going to discuss to you about proving trigonometric identities. The first thing that we need to do, we need to familiarize ourselves with the following formula. For reciprocal identities, we have sine theta equals 1 over cosecant theta. Cosecant theta is equal to 1 over sine theta. Cos theta is equal to 1 over secant theta. Secant theta is equal to 1 over cos theta. Tangent theta is equal to 1 over cotangent theta, and cotangent theta is equal to 1 over tangent theta. Next, we have quotient identities. For quotient identities, we have tangent theta, which is equal to sine theta over cosine theta. And for cotangent theta, we have cosine theta over sine theta. For Pythagorean identities, we have sine squared theta plus cos squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. So, we need to familiarize ourselves with those identities because we're going to apply that so that we can prove trigonometric identities. Let's try an example. Let's prove tangent theta cos theta is equal to sine theta. In proving, we need to prove that the right side is equal to the left side. There are three ways. Either you're going to simplify the right side, or you're going to simplify the left side, or you're going to simplify both sides. So for this one, we're going to simplify tangent theta cos theta, and we need to prove that this is equal to sine theta. So let's try. So the first thing that we need to do, we need to transform or change those secant, cosecant, tangent, and cotangent in terms of sine and cosine theta. So since it is in cosine theta, no need to change this one. Since this is in tangent theta, we need to change this one. Since using the quotient identity, tangent theta is equal to sine theta over cos theta. So instead of writing tangent theta, we're going to write sine theta over cosine theta. Multiplied by, bring down cosine theta. And then equals to sine theta. So we write um question mark because we're not sure if we can get the exact value or we can get the same value for the right and the left side. So next, we're going to cancel cosine theta. So therefore, we prove that sine theta is equal to sine theta. So we prove that the right side is the same with the left side of the equation. Let's try another example. Sine to the fourth theta plus 2 sine squared theta cos squared theta plus cosine to the fourth theta is equal to tangent theta cotangent theta. So as you can see, we can factor this one using perfect square trinomial. So by perfect square trinomial, the factored form of this side is equal to sine squared theta plus cosine squared theta raised to 2. If we're going to simplify this one, we can get this one. Sine to the fourth theta plus 2 sine squared theta cos squared theta plus cos to the fourth theta. So since we're done factoring the left side, we're going to simplify tangent theta cotangent theta. For this one, we're going to simplify both sides. So for tangent theta, we're going to change this using the quotient identity. It will be sine theta over cosine theta. While cotangent theta, using the the quotient identity, it is cosine theta all over sine theta. So let's write question mark because we're not sure if we can get the same value for right and left sides. Sine squared theta plus cos squared theta using Pythagorean identity is equal to 1. So therefore, it will be 1 squared is equal to, we can cancel sine theta for this one, and we can also cancel cosine theta for this one. So therefore, since we canceled everything, it's equal to 1. So let's write question mark. 1 squared is equal to 1. So therefore, we prove that the right side is equal to the left side. Let's try another example. Cos theta over sine squared theta minus cos theta cotangent squared theta is equal to cot theta sine theta. So we're going to change cotangent and cotangent theta for the right side in terms of sine and cosine theta. So let's bring down this one. Cos theta over sine squared theta minus cos theta times, using quotient identity, cotangent is equal to cosine over sine. So we have cos squared theta over sine squared theta equals to cos theta over sine theta multiplied by sine theta. Now, we can multiply cos times cos squared theta. So we have cos theta minus cos all over sine squared theta minus cos cubed theta over sine squared theta is equal to, let's cancel sine theta, let's put question mark, and that's equal to cos theta. Now, we can have cos theta minus cos cubed theta because we have the same denominator. So we have cos theta minus cos cubed theta all over sine squared theta is equal to cos theta. Now, we can factor this because it's just, there is a common factor which is cos theta. So we have cos theta quantity. Cos theta divided by cos theta is equal to 1. Cos cubed theta divided by cos theta, that's cos squared theta. All over sine squared theta. Using is equal to cos theta. Using the Pythagorean identity, 1 minus cos squared theta is equal to sine squared theta. So thus, we can cancel sine squared theta both on numerator and denominator. So we can cancel this one. So therefore, we can get cos theta is equal to cos theta. So we proved that the right side is the same with the left side. Let's try another example. Prove tan x sine x plus cos x is equal to sec x. So we're going to change tangent x and secant x in terms of sine and cosine. Using Pythagorean quotient identity, tangent is equal to sine over cos. So we have sine x over cos x, then multiplied by sine x plus cos x is equal to sec x is equal to, using the reciprocal identity, it will be 1 over cosine x. Now, let's multiply sine times sine is sine squared x all over cos x plus cos x is equal to 1 over cos x. Let's get the LCD. The LCD is cosine x. Cosine x divided by cosine x is equal to 1 times sine squared x is sine squared x. Or sine. So the denominator of cosine x is 1. Cos x divided by 1 times cos x is cosine squared x. Is equal to 1 over cos x. Sine squared x plus cos squared x by Pythagorean identity, that's equal to 1. So therefore, we have 1 over cosine x is equal to 1 over cosine x. So we prove that the right side is equal to the left side. Let's try another example. So in this example, we're going to change tangent in terms of sine and cosine. So we're not going to simplify the right side. What are we going to do? We're going to simplify 1 over tan x plus tangent x, and we need to prove that it's equal to 1 over sine x cos x. So by quotient identity, tangent is equal to sine over cos. So we're going to have sine x over cos x plus sine x over cos x is equal to 1 over sine x cos x. Now, since we divide 1 by fraction sine x over cos x, we get the reciprocal of this one. It will be cos x over sine x plus sine x over cos x is equal to this one. Next, get the LCD. The LCD is sine x cos x. Sine x cos x divided by sine x, cancelled sine x, the answer is cos x. Times cos x, we have cos squared x. Sine x cos x divided by cos x, we're going to cancel cos x, the answer is sine x. Times sine x, we have sine squared x is equal to this one. Next, using Pythagorean identity, cos squared x plus sine squared x is equal to 1. So therefore, we're going to have 1 over sine x cos x is equal to 1 over sine x cos x. So we prove that the right side is the same with the left side. Let's try another example. So for this one, we're not going to transform anymore because everything is in sine and cosine. So what are we going to do? We're going to factor. Since there is a common factor which is sine, so we can have sine x quantity. Sine x divided by sine x is 1. Then bring down minus sine x cos squared x divided by sine x. Cancel sine x. We have cos squared x is equal to, bring down sine cube x. 1 minus cosine squared x is equal to sine squared x. Why? Because of Pythagorean identity that sine squared x plus cos squared x is equal to 1. So it will be sine squared x. Sine x times sine squared x is equal to sine cube x. So we prove that the right side is the same with the left side. So that's all. Thank you and happy math learning. So don't forget to subscribe on our YouTube channel so that you're going to be updated with our math video tutorials. Thank you.